All right, guys, good afternoon. Students online, can you hear me and see the screen? Abigail, Daniel, Jaden, Makino, Najee, why you not in the class?
Yes,
Supposed to
sir.
come face to face. Najee, you're supposed to come face to face. You guys not coming face to face, you're staying home. And stop, keep the online version of this class. All right, let's go through this paper. Share the questions at the back. I would have done them in the marathon the other night. So if it gets too late, I can't get started. Skip over those questions. I would just did them the other night. And the video is there in case you need, right? Last few questions, but I want to go through everything still. But I wanted to grade it. I can always bring up the solution. I agree, but let me work through the first 10. First, no, not 10. First 8. I think I did the last 2 questions the other night. All right. So this is the May 2024 paper. May 2024. And let's get cracking. First question is always calculate a question. So let me get that. All right, let's go. First question says we have to calculate this thing and give the answer first with the 2 significant figures. So let's put this in the calculator. See what it comes out to be. This thing, put it in the calculator exactly that's that appears there. So this thing we'll put in the calculator right now. That's a square root of 7.1 squared plus 2.9 squared. That is it. And that works out on the calculator to be equal to, it is equal to 7, let me stick a thinner, 7.76287 and so on, right? Huh? That's not right? Hold on. Oh, it's 7.1. Oh, good. 7.1. Thanks for that. See, that's why I have to check. Beautiful. That's how I have to check and make sure you type it in the correct way. So you see, even I'm making the mistake that I'm always telling you to do. So 7.6694. Let's put that as 20. I don't think we're going so far. Let's put that as 2. 19. 197955 and so on. Long number. All right. And the question wants us to correct it to 2 significant figures. So we have this number to correct the 2 significant figures. I'll put it here. So 2 significant figures are the first 2 non-zero values from left to right. So that's the first non-zero value from left to right. Hold on a second. Hold on a second. Hello? Hello? It's connected. Hold on a second, guys. I have an important part. Something about the CSEC exam. So give me a second, please. 1 second. Hello? Well, that must be 1 year ago. Could be today. When can I get the SBA for the months uploaded? No, remember I forget I wasn't getting the candidate numbers. It didn't send me the candidate numbers. Huh? No, you sent me the CSEC and the advance, but it didn't send me the pyramids. Yeah, man, just sent me them. Yeah, man. Once you send me that, I'll be able to upload the SBA. All right, cool. All right. All right, guys. Sorry about that. That was about my pure maths exam, pure maths student. All right. So two significant figures. So the significant figures count from left to right, and the first non-zero value in the number from left to right is the first significant figure. So this is the first significant figure. That's the second one. So we are correcting to these two figures. And what you do, you use this 6 to correct that 7.6. And so it's going to increase it to 7.7. So it becomes 7.7 to two significant figures. Two significant figures. That is it. All right. Next thing I wanted to two decimal places. So if I take the same number, hold on a second. Hold on a second. All right. So if I take the same number and copy and put it down here, we now want to correct it to two decimal places. So these are the two decimal places here, the decimal places after the decimal point. So we're using this 9 now to correct that 66, become 67. So it's 0.67 it becomes. So the two decimal places is 7.67 to two decimal places. That is it. All right. This one says now, which are the following quantities? Oh, write the following quantities in ascending order. To write this in ascending order, quick we can do it represent everything as a decimal. Right? It's easier to see what they are if we represent everything as a decimal. We represent this as a decimal first. It's 12 over 25. 12 over 25 is 0.48. So this is 0.48. All right, this is still 0.46. And then this now, 47% is 0.47. Because 47 over 100, 0.47. So putting them in ascending order, this is the smallest one, which is 0.46. Is less than, this is the next one, 0.47. Oh, but I want them back in the same thing. It's less than 0.48. They don't want us to put these. So I'm going to put the actual thing that they gave us. Let me split this out and put the actual thing that they gave us. That will be the order. And the 0.46 is that original one. So they put that here, 0.46. And then the 0.47 is the 47%. They put the 47% here. And the 0.48 is the 12 over 25. So they put the 12 over 25 here. That is it. Ascending order. All right. Next question. It says, Mahendra and Jeha shared $7,224 and they shared it in the ratio 7:5. So like they divided it into 12 parts. One person gets 7 parts of it, another person gets 5 parts of it, 7:5. How much more money does Mahendra receive than Jeha? What we can do, we can work out how much each of them get and then take the difference. Right? So you could say one of them gets 7/5 of that, and one of them get not 7/5, 7/12 of that, and the other one get 5/12 of that. The difference is 2/12. So you could actually calculate 2/12 of this number to see what the difference is. But understand that? Because the difference in the ratio is 2. Right? So you can say it is Mahendra to Jeha, and we can extend it to show the difference. So we can extend it to show the total and also to show the difference between them. So putting in the numbers, it will be 7 to 5. And we extend it to a total of 12 to a difference of 2. The difference between this is 2. Right? And if you want to see what the actual numbers are, you could see what you know what the total is actually. So you want the total column to come under here, the total figure. So you could decide what number do I multiply this by for to show me the actual total. So you can know that number by dividing 7224 by 12. 7224 divided by 12. That number is 602. So if I multiply this ratio by 602, I will know the difference. Multiply this by 602, and that's the difference. Right? Because I multiply by 602 to see what the actual numbers are, the actual values are. When I multiply by 602, this total becomes what it actually is, which is the 7224. And this difference becomes what it actually is. 2 times this 602, which is what? 1204, right? 1204. That's the difference in 1204. And if you wanted the others, you could multiply this by the same 602, multiply this by the same 602. But the difference becomes that 1202. So when you get the total to reflect what it actually is, then the difference reflects what the actual difference is. And if you wanted to know the individual one, could have also multiplied these. But another way we could do it is just to 2 divided by 12, but the difference is 2. 2 out of the 12 times the total will give you that figure as well. Because 2 parts of the difference. 2 parts of the difference. Anyway, the difference is 12. So the difference is so much more than 1. The difference is 1,204. Anybody got that? Got it? Good. So some person would have calculated each of them, I know, 7 over 12 plus, and then 5 over 12, get what the values are, and then subtract them. But if you do 2 over 12 of the total, you're going to get it same way. Get me? 2 over 12. 2 over 12 represents the difference. They could have done 2 over 12 as well. Anyway, let's continue. This part says, the present population of Portsmouth is 550,000. It is expected that this population will increase by 42% in the year 2030. Write 512 in standard, 550,000 in standard form. So this number in standard form, you want the decimal point to become right here, in between the 5s. You want to be the first, you want to have a non-zero digit before the decimal point. So you want the decimal point at the end to come here. So let's look at it. 5, 5, 0, 1, 2, 3. The decimal point is at the end here. You want to move it 1, 2, 3, 4, 5 units to the left. You go to the decimal point 5 units to the left. You can multiply by 10 to the minus 5. This will move it for you. But to cancel out the multiplication by 10 to the minus 5, you know, have to multiply by 10 to the 5 power. So that this and this cancel each other. And this inside here will move the decimal point and put it where you want it. And so it will become 5.5. You don't have to put back these zeros at the end. You don't need them. They become immaterial after the decimal point. And multiply back by this 10 to the 5th power. And that is the answer in standard form. Easy line. All right. Next part says, calculate expected population in 2020. Now, if you're going to increase the population by 42%, then the new population is going to become 142%. It cannot be that way, you know? 142%. You're increasing by 42%. So the new population, the 2030 population, is equal to 142% times the original population of 550,000. Let's work that out and get the answer. So some people would have calculated 42% and then add it. We don't have to do that. So increase up by 42%, the new figure is 142%. You need to understand doing percentages that way. So it's 142% times 550,123. So that's 781,000. So if you do it step by step and do the 42% first and then add it and get the same answer, still correct. Just that you'd have done more work than you needed. All right, that's it. That's the answer for that. Everybody got that one? All right, good. Next question. Give us this graph. It says the graph below can be used to convert between US dollars and Eastern Caribbean dollars. So this is the Eastern Caribbean axis, and that is the US axis. All right. It says use the graph to convert $2 to EC dollars, 2 US dollars. So you're gonna find 2 US dollars up here, come across on a graph and see what it is down on the x-axis, all right? That's what you have to do. So let's look at it. So you want two US dollars. So $2 US here. Right here is $2 US. So you come across on a graph. And then you're going to read it down. So it looks like it is right here. I have to read the scale on the axis before you start to write anything. You want to know what one of these represents. So there are 5 of these intervals between 0 and 1. So that's 1 divided by 5. So each one is 0.2 because 1 divided by 5 is 0.2. So each of those little lines is 0.2 and you cannot double check it. Make sure you get it right. See there? 0.2, 0.4, 0.6, 0.8, 1. So each of these little intervals is 0.2. You have to get that first. This is 0.2. Those little intervals. So therefore, this then is 5.4. See the 5.2, 5.4. Right? So this is 5.4. And 5.4 is $5.40 because it's money. All right, so that is $5.40 EC dollars right there. So this becomes, this answer is US $2 is equivalent to EC $5.40. That is the answer. But go to that. Next question, so we must convert 70 EC dollars to US dollars. But if you look at the graph don't have no 70 on it. But what we can do therefore is just find what 7 is and then multiply it by 10. Make sense? Right? Find what 7 gives you and then multiply it by 10. Because I want 70. So you can find what 7 is. Because the graph don't have any 70 on it. The graph goes up to 10. So if you want to know how you can find what 10 is and then multiply by 7. Right? But I would find what 7 is and then so much is for 7 and then multiply that by 10. Because if you know what 7 is, then 70 is up there by multiply whatever 7 gets by 10. But understand that? So I'm going to find what 7 is first, right here. So I'm going to come over to 7. See how much I get for 7. So I come up on the graph to here, and then read across here. And that is 2 point, y-axis is the same scale, right? 0.2. So this is 2. This is 2.2, 2.4, 2.6. That's 2.6. This here is $2.60. So you can go down here now. So okay, based on that, EC $7 is equivalent to US $2.60. Multiply this by 10. That's like a ratio, you know? The linear relationship. So I multiply by 10. Means therefore that EC $70 is equivalent to multiply by 10, you get US $26. That is it. But I got that. But I got 26. Huh? You got it? Good. All right. Or some people that find 10 and let's multiply the 10 and they get 7 times the 10. You understand? You go get the 10, get what $10 is. And so $70 is $10 7 times. You get me? You can't even do that too. But then anyway, take it. That's gonna be it. All right. All right. Next question. This question says Laura needs to put mesh around 2 seed beds to protect her seed beds. Altogether, I mean total, she uses 60 meters of mesh. So the total around here, because the total around here is 60 meters. All right. It says one of the seed beds is a rectangle and the other one is a square, as shown in the diagram below. it says the width of the rectangular seedbed is X. That's right here. The width is right here, the X. The length of the rectangular seedbed is 3 times the width. So the length here so is 3 times the width, and the width is X. So it means that right here so it's 3X. Over here so it's X as well, and under here so it's also 3X. Then because that is a square, each side is Y. So this is Y, this is Y, that is Y. All right? Question says, use information above to derive a simplified expression for Y in terms of X. Y in terms of X means that you must make Y the subject. The information that we have is that you're using 60 meters of mesh. So the total perimeter of everything must be equal to 60 meters. But understand that? That's what it means, you know. The total perimeter must be 60 meters. So you can write that. Total perimeter is 60 meters. You can say the perimeter of the rectangle plus the perimeter of the square is 60. And that's the total mesh that you use to fence around the rectangle and the square. What's the perimeter of the rectangle? 3x plus 3x is 6x plus 2 more make 8x. So the perimeter of the rectangle is 8x. Plus the perimeter of the square is 4y. Perimeter of the square is 4y. That's 4y. That's all equal to 60. You want to make this y the subject, we can divide 2 by 4 first. We can divide 2 by 4 first. Divide 2 by 4, this becomes 2x, that becomes y, that becomes 15. 60 divided by 4 is 15. Then
We had
make
to
y the
cook.
subject. Make y the subject. We take this
Make
straight and
me fried.
subtract it over here. Mute your mic, please.
Make me fried.
Mute your mic, please.
Yeah.
All right, so the y becomes equal to 15 minus 2x. This is the answer. That's y in terms of x. What do they mean by y in terms of x? Make y the subject. Better go to that. Better go to that. Next question. Next question said the area of the rectangular seedbed is equal to the area of the square seedbed. So the two areas of them are the same. So the area of the rectangular seedbed, so this rectangular seedbed, remember, was this. Rectangular seedbed, for those draw it right here for you. It was like this. And the square one. And it was 3x, x, wrong thing. 3x, x, and this was y, 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 y. Question says, the area of the rectangle and the area of the square equal. That's what they said. Show that this equation is true. Use information to answer the following question, right? Write down a quadratic equation in terms of x and show that it simplifies to this. So the area of the rectangle is equal to the area of the square. That's what they basically, we're trying to prove this. All right? Area of the rectangle is equal to the area of the square. The area of the rectangle is 3x times x. The area of the rectangle is 3x times x. 3x times x. And the area of the square is y times y, which is y squared. Y squared. Notice this equation don't have no y in it. So we're going to have to substitute for this y. What do we know about y? From the top, we know that the y was equal to what? 15 minus 2x. So if we take this, what the y is, and substitute it here to get rid of the y. You get me? That's what we'll have to do. So let me shift this up some more. Now the space is very small. So we're gonna end up getting 3x squared right here equals this thing squared. 15 minus 2x all squared. And then if we continue up here, we have a lot of space. Let me make this smaller. Get a little smaller and shift it over. All right, so if we continue up here now, we're going to expand out this now. And we're supposed to get this when we're done, right? So it becomes 3x squared equal, I'm going to expand this now. So we're going to get 15 squared first. First term squared is 15 squared. How much is 15 squared? 6225. That's 225. And then twice the product of the two. You multiply these two things and double it. Remember, expand on a perfect square that you do. That's what you do. Multiply these two things to get minus 30. And then double it to minus 60x. And the second term square becomes 4x squared. So you get plus 4x squared. Plus 4x squared. All right? And what we're going to do now, we just take this 3x squared, bring it over here and subtract. And we end up getting 0 equals 225 minus 60x. And the 3x squared minus from the 4x squared that gives us 1x squared or x squared. Which is the same equation this really, you know. If we just set it out. X squared, see there, that is, i.e., x squared minus 60x. Minus 60x plus 225 plus 225 equals 0. And that is what they told us to show. That is shown. Star up here, a different color. So we'll continue from here up to here. So, all right, that is it. Next question says, solve this equation. I must use a quadratic formula to do it. So I guess you can't factorize. So we're going to solve this equation using the quadratic formula. We need to find the A, the B, and the C. I use A, B, and C. So A equals 1. That's the coefficient of x squared. The B equals negative 60. And the C equals 25. 225. Remember, the quadratic formula says the x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2 times a. You're putting the values in that now. So x becomes equal to minus b, that's minus a 60, minus a negative 60 becomes a positive 60, plus or minus the square root of b squared, negative 60 squared, same as 60 squared, minus 4 times a, the a is 1, times c, the c is 225, and they divide all of that by 2 times a, and the a is 1. All right? You're going to plug them in the calculator and get the 2 values for x. So let's put them right here. So from this calculation, you're going to get the 2 values for x now with the calculator. Let's plug this in the calculator now and get the 2 values for x. One with the plus and one with the minus. Let's go. 2 values for x. Right? So we're going to get, firstly, a fraction 60 plus, let's use the plus first, square root, 60 squared. It's going to be minus 4 times 1 times 225. I put that all over 2. We're getting 55.98. 55.98. Or x equals, change the plus to a minus in the calculator. I will get 4.02. 4.02. And that's all in meters, right? Everything was in meters. Yeah, because 60 meters of fencing. But what happened now? This answer is not valid enough. Because remember, the total length of the fence was 60 meters, don't it? Remember that? 60 meters was the total length of fencing. And one side of this rectangle is 3 times x. 3 times 50 is 150 already. And we only had 60 meters of mesh, don't it? So this can be a valid answer, don't it? See it? So we cannot accept this answer. This answer is inadmissible. It's not valid. This is not valid. Though it is inconsistent with information. This is not valid. Another way you could know it is not valid is if you try to calculate the y. Remember, the y was equal to, what was it again? The y was equal to 15 minus 2x. So if you do 15 minus 2 times 65, the y will come out negative. Length, distance, they are negative. See that? That's another reason why you could not accept that big value. So the valid answer is this right here. This is the answer right here. This one. This one is not valid. So the x is equal to 4.02. Right? So it's a solve a quadratic equation. That is, it's a calculate the total area of the two seabeds. Remember the other one of the seabed was 3x times x. And the two of them are the same area, don't it? Don't it? Good. So we can just say, okay, since x is 4.02, area of the rectangular bed is equal to 3x times x, which is 3x squared, which is 3 times 4.02 squared, which is what? Which is 3 times 4.02 squared. That is 48.4812. But remember that the rectangular bed have the same area. The square bed, I mean, have the same area. Remember that? Two of them have the same area, don't it? So see it here then. Therefore, total area equals area of the rectangular bed plus area of the square bed. And the two of them is equal. That's all. Remember the question said that? So it becomes 2 times this area, don't it? Because remember that the area of the square bed, the area of the rectangular bed, was equal to the area of the square bed. That's what the question said. So it becomes 2 times the area of the rectangular bed is the total area. So it becomes 2 times this 48.4812 is the total area. So let's multiply this now by a 2 in the calculator, and we get 96.96 meters squared. That is the answer. How many person got this? I remember the year when CSEC set this question, a lot of people complained about it. It was an easy question. A lot of people complain about it, but it's said easy. You never get it right, you need to go and do it over again. Go and do it over. No laugh, I'm serious. No, I improve. So put them set another seabed question. I want similar to this. You don't want to be able to do it. Go and do it over and get comfortable doing it. But you do. All right? That question done. Next question. Number 3. Number 3 said a vertical flagpole FP stands on horizontal ground and is held by 2 ropes PG and PR as shown. So this is a right angle triangle question. So we're going to use Pythagoras theorem and so-called tower. It says PG is 18 meters at that length here. FR is 9.7 meters right here. We can see it there. And the angle inside here is 38 degrees. Everything that they have been writing up here is on the diagram. So we're good. And this angle is 90 degrees. So that's a right angle triangle. That's a right angle triangle. So we can use so-called tower. We can use Pythagoras theorem. It says calculate the height of the flagpole. To calculate the height of the flagpole, we're going to work in this triangle because we have more information in it. So the height of the flagpole is going to be the opposite to this angle, and that's the hypotenuse, don't it? So we're going to connect them with sine. Sine of an angle is opposite over hypotenuse, right? So we want the opposite, and we know the hypotenuse. So the opposite and the hypotenuse are the sides and part, and that's when you use sine, so-called tower. So-called tower. So the opposite you want, and you know the hypotenuse. When the opposite and the hypotenuse are involved, you're going to use sine trig-ratio to do your calculation. So we're using sine in this question. So I'm going to write that sine of 38 degrees is equal to the opposite side at O1, which is the FP, over the hypotenuse, which is 18. You take the 18 and multiply it up here to find the FP. So the FP is equal to 18 times the sine of 38 degrees. You put that in the calculator and you're going to get FP equal. Work this out with the calculator. Anybody did it? Huh? 11.1, all right. 11.1. Put the units of measure, 11.1 meters. Everything is in meters in this question. All right, next question says, so we know that this length is 11.1. As you find information, you put on the diagram. So this length is put on in red. It's now equal to 11.1 meters. That's that distance, 11.1. Next question says, find PR, the length of one piece of rope used to hold the flagpole. That's this piece of one over here. So they don't want us to tell them this length of rope. So we're going to work in this triangle. And it's a right angle triangle where we know two sides. That's hypotenuse. Hypotenuse theorem now we're going to use to find that side. Let's put up here and then copy it down. So this side, this length of rope is going to be the square root of this side squared plus that side squared on a Pythagoras theorem. But you can appreciate that. So it's going to be 11.1 squared plus 9.7 squared. That's Pythagoras theorem. You must know it by now. All right? That's what we're going to be using. Down here. It's not complicated. ER equal. That's Pythagoras theorem we're using. So it's going to become the square root of 11.1 squared plus 9.7 squared. So PR becomes 14.7 meters. 14.7 meters. All right, finish that one. All right, done. That is it. That is it. All right, that is it. Question done. Next question down here. So this question said, diagram below shows, but diagram below, PQ is parallel to MN. So this line and this line parallel. Well, all of this line. All of this line. And this line parallel. So once you have a parallel line, you're thinking about Z angles. Z angles are equal. You're thinking about co-interior angles. They add up to 180 degrees. So for example, if I've joined these two parallel lines with this, then I have formed that Z. See there? I have formed that Z. So the Z here. So this angle and this angle is the same. Z angles. Right? And if I join, for example, these two parallel lines up here, so now, and I join them with this, it means then that angle in here between those two and angle in here, they add up to 180. These two add up to 180 degrees. Stuff like that. So looking out for those things. All right. Well, let's answer the question. Let's answer the question. We're looking out for the Z angles and the co-interior angles and so on, and corresponding angles and things. All right. It says it says LRT is an isosceles. Oh, so LRT is isosceles. LRT is isosceles. It means then that this length equals this length. You can see it. So I'm putting on those marks to say that they're equal. It means that these two angles are the same. See that? Because that's an isosceles triangle. So they didn't put any marking on the diagram for this one, but that is it. So the mark on this and the mark on this now means that they are the same length. It's obvious. All right? And SLT is a straight line. So that's a straight line. We call it a transversal line to these two parallel lines. A straight line crossing two parallel lines, that transversal line. So this straight line will interact with these two parallel lines the same way to form corresponding angles. So for example, the angle up here between that transversal line and this parallel line is the same angle over here. So same angle, corresponding angle. All right? And this one over here is the same as over here, corresponding angles. All right? But we know now that these two angles are the same. But that's an isosceles triangle. All right, let's answer the question. It says, find the value of x find the value of x. Anything else? Or they just want the value of x. All right. So to get the value of x, we're gonna have to work down. All right. I just say I'm multiple ways to do this. What we can do, we can find this angle and find this angle. And we can recognize that this angle x is the same as this angle x. This is also x. So if we find this angle, then we also have that angle, don't it? See that? That's one way to do it. There are multiple ways to do it, but I think maybe that might be the easiest. We're going to find the theta, because those two angles, theta will be the same. We'll call it theta. So in our diagram, the theta is going to be 180 degrees minus 28 degrees divided by 2. But I give you that on that diagram. We put in those two angles and call them theta. That's a good way to do angles sometimes. You give them a reference. Right? So it's going to be 180 degrees minus 28, and you put that over 2. So that is 76 degrees. And then right here, so the x is equal to total along a straight line. Total along this straight line is 180. So the x is equal to 180 minus the 76. Everybody see that? So the x now is equal to 180 degrees minus theta. So the x is equal to 180 degrees minus 76 degrees. Much is that? Minus 74 to get 110 minus to get 104. Why is that? 104 degrees. Show another way we could have gone. So we still need to find the theta. But we could have found this theta instead. Now watch this now. Because of this said right here, it means that this angle in here is also 28 degrees. So the angle here and the angle is the same. It's 28 degrees. So 28 degrees. Right? And then now, if you look right here, where these two angles cross each other, these two lines, this line and this line cross each other. Then the x over here is always color. It means that green. Here's the green. And this angle over here, which is the x, is equal to the whole of this angle across here. So they call it vertically opposite angles. Because angles on the opposite side of our x are always equal. See that? Vertically opposite. So you see the x over here, so that we want, it is equal to the sum of theta and the 28. See that? Because they are vertically opposite angles, they're equal. Those two green angles are equal. So I use the blue lines to form like an X. Right? It's just that I draw this one bigger, but I'm talking about this green angle here. It's the same as this green angle here. But I put it out here out of the way. You understand? Those two green angles are the same. You get me? So another way we could have done it. So we could have said or we could have said x is equal to theta plus 28 degrees. So the x would be 76 plus 28. Get the same thing. X equals 104 degrees. Right? So this calculation is what we did right here. While this calculation is what we did up here. That is it. So two different methods. And if I look closely, I might find even other ways to do it. Two ways. Very good? All right, that is it. Next question. Give us this transformation. It says, diagram below shows a shape T and its image Q. So going from this to this, right? No, this to this. Image is Q. So transformation in this way. That looks like a reflection. It said after a transformation, and I don't tell you what it is. It said describe follow the single transformation which maps T to Q. What transformation maps this to this? I can say as a reflection. A mirror line will be right on the middle right or so. Mirror line going right down the middle there. So. Alright. Now, if you're not sure, you can use a process of elimination. One is not a translation. Because translation, image and object were the same, don't it? It just move from one place to another. This clearly turn, right? Some kind of turning or flipping around take place from this to this. It's not an enlargement because the two sides are the same. So it's not an enlargement. So it's not whether it's a reflection or a rotation. So the side of the reflection or a rotation, you can check the orientation of the letters. If the orientation is reversed, you know, it's a reflection in a line. So because they don't give us any points, you can put on some points on it for yourself. So for example, you can call this point A, this corresponds to A. You can call this vertex over here, so B, this corresponds to the B. They can call this vertex C, and this one corresponds to C. If you look at this one now, the orientation is anti-clockwise, A to B to C. A to B to C, and this one is this way. So the orientation has been reversed. The orientation and the image and the object are opposite, one clockwise and one anti-clockwise. So because the orientation is reversed, you know you have a reflection in a line. And the mirror line is halfway on the line joining corresponding points, halfway between them. The mirror line is always going to be halfway between them. So these 2 points, halfway between them is here. These 2 points, halfway between them is here. So the mirror line clearly going right up between them like this. So that's simple as that. So let's draw it. This is the mirror line. So you decide the reflection, and you don't, the mirror line is right between them. So it's right in this intersection here. So that is the line that passes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So that is the line y equals x. So it's a reflection in the line y equals x. Good? It's a reflection in the line y equals x. So transformation is a reflection in the line y equals x. And you can't just see the reflection in the guys. You have to give the components of reflection. You have to give the mirror line. Reflection, you must always state the object that you're reflecting in. Or reflecting over. You're reflecting in line y equals x. So you have to state that mirror line. You cannot just say it's a reflection without stating the mirror line. See? Describe fully. That's what fully means. Fully means you give the name of the transformation and the component of the transformation. Component of a reflection is the mirror line. All right? State the mirror line. All right? Or if it's a point, you can also state the point of reflection, the point that you're reflecting through. This one says no. Draw on the diagram, draw the image of shape T after it undergoes a translation, -1, 6. So this -1, 6 translation, let's remind ourselves of what it does. -1, 6 translation. It means -1 means 1 to the left. You're going to move a point 1 to the left first. That's -1. 6 here now means 6 upwards. That's what it's going to do to a point. See that? That's what it does. So just take the image now and move it 1 point to the left, 6 up, and then draw about the same shape around that point. That's how we have to do for the translation. All right. So which one I must do it to T and label it M. Right. So we do a translation on this one. Let's do it out in purple and then draw the image in blue. So let's use this point. And then draw about the same shape around that point. So 1 unit to the left, which is right here. One unit to the left is this. And 6 units up. 1, let's count it off. 1, 2, 3, 4, 5, 6. So that point is coming up to here. 1 unit to the left, 6 up. So this point is coming up to here. So you can now say 6 up for Trinidad. From 1, you climb 6 up to 7, right? So that this point is coming up to there. So once you reach up there now, you just draw about the same shape up here, so around that 1 point. Same shape. So see here now, this piece from it was 3 units. You draw this 3 units same way from this point. 3 units. Start going so good. 3 units here, so. And then this piece was 2 units up after that. So you draw this 2 units up as well. 2 units up. Then this piece was 1 unit across at the top. So you join this now 1 unit across at the top. Then this now completes the shape. That diagonal line completes the shape. So just complete the shape with this diagonal line as well. That is your shape. You label it M. That is it. So we went 6 units up and 1 unit to the left. What good at that? But all right? All right. Next question. We shall draw it in a blue. Change it to blue. Change this to blue. That's it. Anyway, let's finish with that question. Let's go on to the next one, number 4. Number 4 said a rectangle PQRS as a diagonal, a rectangle PQRS as a diagonal PR, where P is the point negative 310. Let's write them out. P is the point negative 310. And R is the point 4 negative 4. R is the point 4 negative 4. All right? It says calculate the length of PR. That's the length of a line formula. Remember, length of a line is the square root of the difference in the x value squared plus the difference in the y value squared. Remember, it comes from Pythagoras' theorem. All right, that's how we're gonna get it. So see it here now, length PR. Gonna be the square root of the difference in the x value squared. So x value, you know, this one minus this one. I have to bear in mind the sign that is there. So it's 4 minus a negative 3 squared. Because difference in the y value squared. That's negative 4 minus 10. That's negative 4 minus 10. And squaring that. This becomes 7. Square root of 7 squared. This becomes negative 14 plus negative 14 squared. All right, and you can just put that in the calculator and see what we get. So the square root of 7 squared and negative 14 squared, same as 14 squared. Right? So you can put 14 squared. At 15 point something, let's see if we get it as a search form. So it's absolutely equal to this. 7 times the square root of 5. So some character will give you that. If I can put the 15 point something, I'm going to put 7 times the square root of 5 for an exact answer. So it's 7 times the square root of 5 and it's units. Length in coordinate geometry is in units. You must always write over the units when you calculate length in coordinate geometry. Unit squared, we calculate area in coordinate geometry. So it's units. All right, next part wants the equation of the line. So to find the equation of the line, we need to know the gradient and a point. We have 2 points. We can use any one of them. But the bottom line, we need to find the gradient first. All right? We're going to call the gradient M. Remember, gradient is difference in the y values over difference in the x values. Because it is rise over run. Rise is difference in the y values. So you're subtracting the y values now. You're careful with the signs. So remember, the direction you go when you're subtracting the y values, you must go the same direction when you're subtracting the x values. So let's say we're using this y value minus this y value. That's negative 4 minus 10. Negative 4 minus 10 divided by, I have to use now this x value minus this x value. That's 4 minus a negative 3. That's 4 minus a negative 3. This minus minus here becomes a plus again. So it becomes equal to negative 14 over 7. Because as I said, this minus minus becomes a plus. Negative 14 over 7 is negative 2. So the gradient is actually negative 2. All right? And then now, don't give a lot of space. Then now, pass through these 2 points. You can use any one of them you want. Let's say we're using the point P. Let's say we're using the point P. You need a gradient and a point. So let's say we're going to use P, which is negative 310, to get the equation. Then the equation is going to be y minus the y value at P equals the gradient into x minus x value at P. That will give you the equation straight. Some people use y equals mx plus c. Put a negative 2 right here, so for the m, and get y equals minus 2x plus c, and then plug the values in there to find the c, which is okay. If you do that way, fine, no problem. But the beauty about this one is that you get the equation straight. It gives you the equation straight away by plugging in these values. So the y value at the point P is coming here, which is y minus 10 equal the gradient of the line, which is negative 2, is going there. Minus 2 into x minus x value at the point is this negative 3. So it becomes x minus a negative 3. This minus minus here again is a plus. So this is a plus. That's a plus 3 it becomes. So if you simplify that a little bit first by expanding with this negative 2, we're going to get y minus 10 equals negative 2 times x is negative 2x. No, this is negative 2 times positive 3. Negative 2 times positive 3 becomes negative 6. Then this 10 comes over, becomes a positive 10. And the 10 minus 6 is 4. So the final equation then is y equals minus 2x plus 4. That is the answer. How do you go to that? Y equals minus 2x plus 4 is the final answer for the equation. If you use this point instead, you get the same answer. If you choose use this as your known point, you get the same answer. But I decided to use P in this example. All right? Let's continue. Down here now is functions. This question gives us 2 functions, f and g. First one wants f of x minus 2. It means I want to take x minus 2 and replace the x right here. That's all. All right? So if this is f of x, then f of x minus 2 means that this becomes x minus 2. So it simply becomes equal to 3 times x minus 2 where the x is plus 1. Plus 1. So where if x was, I put x minus 2 there. And we can simplify it and say express simplest form. So 3 times x is 3x. 3 times minus 2 is negative 6 plus the 1. Negative 6 plus 1 is negative 5. So we get 3x minus 5. That's the answer. 3x minus 5. All right? Next question. The one g of x plus 2 plus 10. Same thing again. I want to take the x plus 2, 3x plus 2, and substitute for the x right here. Let's write it out. The g of x, remember, the g of x is x squared. That's what they gave us. The g of x is x squared. Good. So the g of x plus 3x plus 2 means that we're going to change this. to a 3x plus 2, and I want to add 10. So this thing becomes equal to 3x plus 2 squared. This part of it is this. And then we have to add the 10 plus 10. I have to simplify this now. So we're going to expand this perfect square. Remember, when you expand a perfect square, you get 3 terms. You get the first term squared, which is 9x squared. Then twice the product of a 2. The middle term is twice the product of a 2. What you do twice the product of 2? Multiply these two things. 3x times 2 is 6x, and then double it. Double the 6x to 12x. So the middle term is 12x. And then the second term is squared there, so which is 2 squared is a 4. Square the 2, you get 4. So expand this, that's what you get. And then we're adding back this plus 10 out here, so now plus 10. And you simplify, you can add these two values now, like terms. You get 9x squared plus 12x plus 14. And that is the answer right there. Nice and easy. I like this question. If you never get it, go and do it over. Make sure you get it. All right. Next question. Oh, that one done. Number 5. Number 5 looks like a statistics. Said Mr. Morgan administered a spelling test to his class. The table below shows the number of words out of 10 that each student got. So this is on-group data. On-group data. So these are this is the data number of words. This is the frequency. So this is the number of students who get 5. It's 8 students get 5. 4 students get 6. 2 students get 7, sorry. 2 students got 8. 3 students got 9. And 4 students got 10. All right? It says, what is the mode? The mode is the score. These are the scores. Those are the scores. These are the frequency. The mode is not a frequency. The mode is a score. It's a score with the highest frequency. So the highest frequency is 8. So the mode is 5. You see that? So the mode is equal to 5. And it's 5 spelling words, 5 words. Table below, number of words, 5 words. Or 5 correct words. The table below shows the number of words over 10 that each student got correct. So it's 5 correct words. The mode is 5 correct words. All right. So this is the mode. Or this is matches the highest frequency. All right. The mode is 5, highest frequency. That is the median. So to find the median, you have to find the score that is in the middle of the distribution. So you have to add up the frequency and count until you reach the student in the middle. Now, how many students were there now? Did you tell us how many students? It's a number of students. So we have to add up the frequency to know the number of students, and then add up until you find the number of students in the one in the middle. But the median is the score of the student in the middle, right? Good. So how many students are there? Total here says how much? How many students total? Add up this for me and tell me what you get. How much? Huh? Why that tell me something different? Okay, add up them for me. 8 plus 4 plus 2. 2 and 2 is 4 plus 7. 23 students. So if you have 23 students, the median corresponds to which one? Remember, if you have 22 students in a line, and you take out the median, you have 22 left. So you have 11 and 11. 11 up below the median and 11 above the median. So the median corresponds to the 12th value. Remember that? 12th value. But you can also calculate it using the formula that I showed you. Position of the median is half of the n plus 1 term. See here? Let's do it over here. So portion of the median. The position of Q2 when the data is on group, this is on group data, is half of the n plus 1 term. Shift this over a little bit. It's the position of Q2. That becomes half of 23 plus 1 term. That's half of 24. That is the 12th term. Same 12th term that I looked at a while ago. So you need to find out which is the 12th value. So you're going to come up here now and start to add up the value then. So to add up the value, that you need a cumulative frequency, which is the counting, your way of counting the values. Remember, the cumulative frequency is for you to count how many values you have. So you're going 8 values so far, and then you're going 4 more values here, so make 12. So you have to reach a median already. So the 12th value is one of these. So the 12th value is a 6. You see that? See that? So the 12th value is a 6. So the 12th score is Q2, which is equal to a 6. So the median is 6. What is that? So the median is 6. So based on that, Q2 is equal to 6. Correct words. 6 correct words. It's Q2. All right. Next one. Calculate the mean number of words spelled correctly. The mean number of words spelled correctly. So you want to know the total number of words spelled correctly divided by 23 students. So to find the total number of words spelled correctly, you can multiply these values. If I say 8 students spell 5, that's 40. 4 students spell 6, that's 24. You understand that? So we can actually do it roughly here, so you know. Right? So you can work it out and say, okay, 8 students times 5 words, 4 students times 6 words, plus 2 students times 7 words, 2 students times 8 words, 3 students times 9 words, 4 students times 10 words. That's the total number of words divided by 23 students. But I understand that rough calculation. Based on how they give us a table. Unless you're gonna put in an FX column or FX row in this case, because the values are in a row, not in a table. You put in an FX row to calculate the sum of the values. All right? We can do the calculation straight. All right? Can do the calculation straight. So this becomes equal to, see here now, the mean is the sum of the frequency times the score divided by the number of scores. Frequency times the score. So the first one is 8 times 5. You can add them up right here. So 8 times 5 plus. The next one is 4 times 6. Next one is 2 times 7. See there, 2 times 7 and then 2 times 8. 2 times 7 and then 2 times 8. That's the sum of fx, you know. We calculate f times x, f times x, f times x, f times x. And we're adding them up. This means they add them up, the sum of fx. Where we reach now? Which one we reach? 3 times 9 and 4 times 10. 3 times 9 and 4 times 10. Shift this over. 3 times 9 and 4 times 10. So we're gonna add 3 students got 9 and 4 students got 10. That's the total number of words, correct? Divided by total number of students. The number of students is 23. Word that out and get the mean. 7 again. That's how you did it. I do the table. They put on the table. Table do it just like this. Beautiful. Beautiful. All right. So once you get 7 exactly. You get 7 too? 7 correct words. A bright man. Good. 7 correct words. Ah, beautiful. Next calculation. Or they give us a activity frequency curve. It said the attendance officer at a particular school recorded time in minutes taken by each student in a group to travel to school. The data collected is shown in on the cumulative frequency below. So remember now, once about cumulative frequency curve, it means that the data was grouped. It was derived from group data. So the graph is either a graph showing less than time or less than or equal to time. Sometimes I don't know off the bat until they start to answer the questions, whether it's showing less than or less than or equal to, right? Question says, use the cumulative frequency graph to find an estimate for the number of students who took at most. Now, at most means less than or equal to 32. At most 32 means 32 or less. So based on that, now we can say this graph is showing us less than or equal to time. Just based off of the first question there. You understand me? At most 32 minutes means 32 minutes or less. 32 minutes is the most. You want to know. So the graph is going to show you that. So you just find 32 on the graph and see how many students you get for it. That's all you have to do. Find 32 on the graph. So we're going to read the scale properly now. So based on the scale, this is 2, 4, 6, 8, 10. So every one of those millimeter lines is 2 units. So 32 is right here, don't it? That's 32, right? 32. So you come upon that 32 line till you reach the graph. Looks like it's right there. Come across. And that looks like 40. This is 20 units. You have to be careful now, you know. So that 20 values divided by 5 lines. So each of these little lines is 4. See? Each of these little lines is 4. You have to make sure you get the scale properly, guys. Each of these little lines is 4. You have to always be careful with the scale. Don't just start reading values. So this is 40, 44, 48, and 4 more make 52. So that's 52. See that? So this is 52. 52, that is. The answer is 52 students on the graph. And all you have to write it down because the marking on the graph is what you use to show where you get it. Right? So this is 52 students. 52 students. But spend less than or equal to 32 minutes. 52 students. Next question says the interquartile range. So the interquartile range, you remember now, is Q3 minus Q1. So we need to find the Q3 and find the Q1 and subtract them, right? So to find the Q3 now, how many students are there? 220. So the position of the Q3 is 3/4 of 220. Position of the Q1 is 1/4 of 220. See that? So let's work out what that is. 3/4 or 75%. So it's 0.75 times 220. That's 165. So we're looking for 165. So this is the 160 here, so remember that every mark is 4, right? But I will keep question to give us 165. So this is 160. This is 164. 164. This is actually 168, you know. So 165 going to be in between here, so it's an estimate. You're going to put it anywhere in between there. You understand me? As an estimate. It's an estimate. So I'm going to put 164 right above the 165 right there. So put that as 165. 165. Right? 3/4 of 2. It was actually 220 students all the way up to 220. It didn't tell us how many students. But based on the graph, we come up to 220. We're going to say it's 220 students, right? So come across on the graph now on this line and see what we get. Till you reach the graph. Straight across here. And it looks like it's on this line right here, so now. Looks like it is right here. Looks like it is right at this mark, which is 54. Remember, every mark is what, 2, right? So it says 54. And that is our Q3. And this was the position. Let's put it up here. So this was the position of Q3. Position of Q3 was 3/4 times 220. That's how we get the 165, right? 3/4 of 220. And the portion of Q1 was 1/4, which is 0.25. 55, looking for 55 now. So 55, this is 54, 52, this is 56. That's 56 enough. Sorry. So this is 56, this is 56. So 55 is just below the 56. So I'm going to put it right here. Then I know to put this as 55. That's the position of Q1, which is 1/4 times 220. That's how we get the 55 position. You come across on the graph and read it down. So it's just up below this line. And it looks like over 32 here. For the 31 a year. So. Look like we know this line right here. That looks like about 33. That looks like about 33. All right, so I'm going to say right here is Q1. I'm going to put that as 33. All right, yes, and that. All right, working with 220 students. Don't write these numbers, but anyway, that is it. So the Q1 is 33 and the Q3 is 54. So it's gonna be equal to 54 minus 33. What is that? 21? 21 students. No, 21 minutes. Not student, 21 minutes. The data is in minutes. 21 minutes. That is it. All right, that question done. Then the drop in this probability question on us this year. Don't know where it came from. Land this probability question. But we're going to talk about probability and so on, all the sets, right? What the topic of sets. But I don't normally say probability question here. So key thing to remember about probability that you have two events, probability of two events, one and the other. You multiply the probability and the probability of something or something else, then you add the probability. So generally speaking, and you're gonna multiply or you're gonna add. All those sets, you add it a little bit more. All right? All right. So this question says the letters in the word positivity are each written on separate cards and placed in a bag. This picks two of these cards at random with replacement. With replacement means that she take it out and she put it in back. That's what with replacement. If it was without replacement, instead we should take out a card, she's not putting it back. So the probability would have changed, or the sample set would have changed. So how many words is? How many letters is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if she was taking out two letters, right? When she take out the first letter, it's 9 would have left out of it. So the probability of getting the second one would have been out of 9. But because she's putting it back, the probability of getting the second one is now still out of 10. Because she's putting in back the first one, right? So that's how the with replacement, without replacement kind of work. It just comes to logical reasoning, right? It says, find a probability that she picks an I and then a V. This is an AND. It then means and. So she wants a probability of doing an I and a V. We call it consecutive events. Consecutive events. Something against and then something else. When you do the probability of consecutive events, you're going to multiply the individual probabilities. So this becomes equal to the probability of doing the I times the probability of getting the V. For the AND, consecutive event is the AND. And it is with replacement. So look at it now. When she take out the I, what's the probability of getting an I first? How many I's are there? 1, 2, 3. So probability of getting an I first is 2 out of 10, right? So imagine she said go in there, she take out the I, that's 3 over 10. But she put it in back. So she's still not gonna get a V out of 10. Because still 10 in the back, and she put it in back because it is with replacement. If it was without replacement, then the probability would have changed to 9. And you only have 2 of the I's left in the back. You understand? If it was a without replacement, you say, okay, probability of taking out one of the I's is short of 10 still, and you're gonna have 2 I's left. Imagine thinking that one of the I's come out. So probability now would have been these values now out of 9. So she wanted another I, it would have been 2 out of 9. And she wanted a V, it would have been 1 V out of 9. But because it is with replacement, the probability is now out of 10 again, because she put back the I in the back. Let's imagine she put back the I in the back. And now she wants to get a V, but there's only 1 V. So that is now 1 out of 10 again. See that? So that becomes equal to 3 out of 100, and that is the answer. 3 out of 100. If it was without replacement, it would have been 3 out of 10 first times 1 out of 9. If it was without replacement, meaning that you're not putting in back the I. Just imagine she take out the I first, she's going to know have 9 letters left in the back. But there's only still 1 V in there. You see that? So the probability of getting a V for the second chance now would have been 1 out of 9. If it was without replacement, they just change this and put without replacement instead of with replacement. But understand that? Good. So you can set a question like this next time and just change this word to without, And that's how we have to change, right? Just imagine, put it in a real sense. So don't put it down there, so. And say without replacement. Down here, so it's without replacement. Without replacement. This should be the answer. So without replacement, if it is without replacement, that will be a calculation. Right? For the same I and then V. Right? Good. All right. Number 6. So once you see this, so some circular measures come into play, right? The diagram below shows a gold bar in the shape of a trapezoidal prism. It's a prism, meaning the end of it is a prism. It's a trapezium. Right? Remember, for object with uniform cross-section like this, volume is cross-section area. The tree formula is this. Volume is cross-section area times length. Curved surface area is perimeter of the end and the length. Total surface area is the curved surface area, which is this, plus the 2 end areas. A means end area. And the end area is the cross-sectional area here, so that area there, so. And the length, the distance between the 2 ends, which is this. This is the L. This will be the L. And the P, the perimeter, will be the distance around the end. The distance around the end is the P, the perimeter of the end. Those are the 3 formulas that governs everything relating to uniform solids. These 3 formulas right here, so. All right. The question says, it shows a gold bar. It's the volume. So they give us the volume. We know the volume. The volume is this. So this is the V. 288.6 It says the length and height of the prism are indicated. Now, this is the length. So this is the L. This right here is your L in the formula. This is your L. This thing is your L. All right. It says calculate the area shaded. The end area that I want to know. The area shaded, the end area. This is the A in the formula that I want. So see here now, that is the A. Volume equals end area times length. Therefore, end area equals volume over length. The volume is 2886 and the length is 31.2. So the end area, the area shaded region, is this calculation right here. Simple as that. That's why it's 1 mark for it, because it's very easy. All right, so that is it. So it's just make sure the volume is in cm cube. I'm working in centimeters, yes. And the area is going to be in centimeters squared. So it's 2886 over 31.2. That's 92.5. 92.5 centimeters squared is the end area, the A. The end area, cross-section area. 92.5. Next one. It said the cuboid gold bar shown below has the same volume. So the same volume. So the volume here is the same. V equals 2886 cm cube. Same volume as the trapezoid prism at this place. So this one now, this is the L. This is the L. This is the L now on this one. Using the same formula again. All right. It said calculate the height H. So we're going to find the cross-sectional area again. And the cross-sectional area becomes this length times the H. That's what we're on in this time. So they have the H up here. This is the H. This is the H. The same H over here. So for this one, the end area becomes 8.2 times H. 8.2 times H is the end area. So you're doing the same thing down here now. Volume is end area times length. The length is this. The volume you know is this. And the end area is this. You're putting everything in this formula. So we can put everything in there. So the volume is this figure. All right, so we can write 2886 is the volume equal. The end area now is this, 8.2 H. But the end area will be length times width at the end. The end area of this rectangle at the end is those two dimensions, 8.2 times H. So this area becomes 8.2 times H. 8.2 times H. And then the length of this thing is 30.6. The length is always the distance between the two ends, two cross-sectional ends. That is the L in this question. So the L in this question is 30.6. Let's try to find the H here. So divide them two values under this. Take this and divide it under here. Take the 30.6 and divide it under here as well. You get the H. So the H becomes equal to 2886 over, divide this under there. You get the 8.2. And also divide in the 30.6 under there. But understand that? But I get that? Divide this under there and divide the 30.6 under this as well. And leave the H as the subject. I just turn it around. Where the total have the H? So the fraction 2886 over 8.2 times 30.6. I get an 11.5 centimeters. That's height each. To one decimal place. So 3 significant figures. That is the height each of this cuboid. That is it. Next question down here. It says the trapezoidal bar is melted down and all the gold is used to make 6 identical spheres. So all the gold is the same volume. 2886. It's 2886 cm cube. Is now used to make 6 identical spheres. So the total volume of the 6 spheres equal this. Right? It says calculate the radius of calculate. It says for each sphere of gold, calculate its radius. And they're telling us that the volume of a sphere is this. So see it here now. Watch this now. 6 times the volume of a sphere, of the sphere. Right, 6 of them, you know. The 6 spheres is equal to the volume of the gold, 2886. Why can't I say that? 6 times the volume of one sphere. Right? It was converted into 6 spheres. So the 6 spheres have this volume. So they want to know what's the volume of one sphere. In fact, they want the radius. They want the radius, but we can get the radius from the volume. But this is the formula for the volume of a sphere. Right? So the volume of a sphere is this formula right here. The question is asking us for the radius R. So we're going to write 6 times the volume of a sphere now is 4/3 pi r cubed is equal to this number, 2886. And in all this calculation, we're trying to find the R. But then must use pi r in this question. 22/7. So from all of this now, we're just trying to find the R. Must be 12. Trying to find the R. And this is 22/7. So we can do like this. What this becomes? This becomes 8 now. Because this into this goes 2 times and 2 4 is 8. But can say that? This right now becomes an 8, right? But say that? So you're going to get 8 times 22/7 times r cubed equals this 2886. So to make r cubed a subject, we multiply the 7, divide under the 22, and divide under the 8. Or if you like, you could multiply the 8 times 22 from now. But we can go like this. The r cubed is now equal to, transpose it, 2886. Take the 7 and multiply it beside it, times 7, divided by the 22, divide the 22 on a year, and divide the 8 on the year as well. So divide by the 8 and the 22. And then if you want to find the r, you can get rid of this cube by cube root in both sides. So if I come now and I cube root this side, and cube root this side, then the cube root cancels away this cube, and this becomes just an r. And I'm left with this calculation. And whatever that works out to know is my r. So r equals whatever that becomes. So r equals whatever this is. So I can put that in the calculator. Cube root of a fraction 2886 times 7 over 8 times 22. And that's 4 point. Did they tell us how accurate I want it? Let's put 4.86. 4.86 centimeters. Give it to 3 significant figures. But I got that? 4.86. Next part now says the surface area, calculate for each sphere, for one sphere, the surface area of one sphere. So surface area of a sphere is 4 pi r squared. This is a formula. So surface area of a sphere, let's put the sphere right here. So formula is 4 pi r squared, which becomes 4 times 22/7, and the rest is this, times 4.86 squared. And you work that out to the calculator, you have the answer. Equal, and you put it in square. So it's 4 times fraction 22/7 times 4.86 squared. So we're getting 296. 0.9 centimeters squared. It's area and so it's in centimeters squared. That is it. Very good. That is it. It says now, must also find the mass to the nearest kilogram, given that the density of the gold is this. So the mass of the sphere we want again, the mass of the sphere. Right? And they are saying that 1.3 gram, 19.3 gram is 1 cm cube. All this means, you know, guys, all this means is that 1 cm cube of gold is equivalent to 19.3 grams. And I want us to now tell them what is the mass of this sphere. Right? Remember, say the volume of a sphere is this, you know, and I want us to convert this volume now to mass. And this is the conversion based on the material, based on the density of the material. 1 cm cube of the gold, this amount of kilograms. And what do we have? We actually have this amount of kilograms, this amount of cm cube. No, not on the cm cube. Cm cube was the other one, sorry. The volume of, what is the volume of, oh, so we need the volume of one sphere. So we divide it by 6 to get the volume of one sphere. See that? We get the volume of 1 divided by 6. So let's go down here and do that. So the volume of one sphere, the volume of a sphere is 2886 divided by 6. What that work out? That's the volume of one of the spheres. 2886 over 6. So it's 481. 481 cm cube. So it's easy now. If 1 cm cube is this, and you want to know what 481 cm cube is, let's multiply it by 481, don't it? So that? So you can say, therefore, this is the mass, this is the volume of one sphere. So therefore, the mass of a sphere becomes 481 times this, 19.3 grams. Because if 1 cm cube is 19.3 grams, then 481 cm cube is 481 times 19.3 grams. But the question wants us in kilograms. So I'm going to get the answer, we'll divide by 1,000 to get it in kilograms. Right? But to go from grams to kilograms, we divide by 1,000. 1,000 kilogram make a 1,000 gram make a kilogram. So we're doing 481 times 19.3. That gives us 9283. No. 9283 grams. Divide this by 1,000. 1, 2, 3. Put the decimal point here. It becomes 9.2833 kilograms. But the question said to the nearest kilograms. I mean, say now you run it after the nearest whole number. That's what nearest kilogram means. You run it after the nearest whole number. So the nearest kilogram means that you're going to run it after the nearest whole number. So it's going to be 9 kilograms. That is the answer right here. 9 kilograms. All right? So I have to work what the mass of one sphere was. But they give us the density up here. So 1 cm cube is 19.3 grams. So we have to convert the volume of our sphere into grams. And then divide by 1,000 to get the kilogram. That is it. All right, that is that. Next question. Pattern. Question says, diagram below shows the first 4 diagrams in a sequence of regular hexagons. Each regular hexagon is made using sticks of unit length. All right. So basically, I want to see how they go from one to the next. That's what we have to observe, how they move from one to the next. So from this to this, what you can do now, look for this shape in this first and see what was added. So this is the original shape right here. This is the original shape that was here. So I mean that this is added to it. This is what is added to it. That's what was added, right? But you can read that. What is in red is what we keep adding. So keep adding two square, two of those hexagons to each shape, right? See it? Keep adding two. See? So this was the original shape that we had a while ago. And then now adding on this to it up here. So we keep adding two hexagons to the shape, to each shape. So realize that. Question now says, complete the diagram below to represent diagram 5. So you see what happened now? This is really diagram 4, you know, but they left off some of the hexagons. They left off one here, so they left off one there, so. We put on back those two first, and then add on what we're supposed to add on. You get me? All right. So let's see what we can do. So we need an hexagon inside here. So like this is missing from here. And what is missing from here? What is missing from over here? This is missing from here. So far, so good. We need to add on two hexagons, right? So we're going to copy two hexagons and add it on. I can do it. No one can do it, but I can do it. So stop in here. Wait up. Sure. Oh, right. So I'm going to add on the two hexagons now. So when they keep adding on, let's draw what them add on. They keep adding on this thing. Let me draw it in red. Keep adding on this thing. That's what they added on. That is what was added. So I'm going to copy that down. And I'll put it here. That's right. So missing, let me see. Go back up. Oh, looks like the size different. Okay. Size is different. I'm just make it a little bigger. Something like that. Size, just like the size is different. It's different. Bigger down here, so. There you go. That's it. That's what you're supposed to draw, guys. Want to pick up the pattern, right? That's supposed to be a figure 5. Right? So complete the missing pieces down here, and then add on the one on the top. Let's look at it and make sure. That looks like it. Very good. So, 1, 2, 3, 4 lines. 1, 2, 3, 4 lines. Another line. Just making sure. All right, that's it. Then we come to this table, and oftentimes you don't need the diagram to help with the table. Just follow the pattern on the table itself. So the pattern of the shape, your pattern of the numbers. You can work the pattern of the numbers by themselves. And the information up here, the same thing all the time. It basically tell you that it follow the pattern and all these things, right? The number of hexagons and the number of sticks. Number of hexagons is H, number of sticks is S, and the perimeter of the shape is P. And they follow a pattern. And the first 4 in the diagram are shown to below. Study the pattern and complete these rows. 1, 2, and 3. So as usual, I like to fill out this one first because it helps us up here a lot of the times. I end up to have to be figuring out stuff. All right, so let's look at this one. They keep adding two hexagons. We know it was adding 2 hexagons, don't it? The formula starts with 2n. But the first figure is 3. 2 times 1 is 2. You have to add 1 to make it 3. So it's 2n plus 1 is the formula for that column. Just the perimeter, what are they adding here? This plus this is how much? 8. That's 8. 8. Is 8 again that to get this one? Yes, I keep adding 8, right? So because I keep adding 8, the formula starts with 8n. But the first figure is 15. 8 times 1 is 8. If I add 7 to that, that's the formula. If you're not sure, you can try the 2 on it to see if it works. 8 2 is 16. 16 and 7 is 23. So you know, say it right. See that? So you can try the formula that again. Then over here, this one going up by what? By 4, don't it? So I'm going up by 4. So the formula starts with 4n. But the first figure is 12. 4 times 1 is 4. You need to add 8 more to make it 12. So 4n plus 8. That's true. You can try the second one on it. 4 2 is 8. 8 and 8 is 16. So you know, say your formula good. Formula good. They can use it to help you now. So for figure 5, you can put a 5 on here. 2 5 is 10. Then I want to make 11. But the next shape, so just add the next value to this, I get 11 anyway. For this one, just add 8 to this. 39 minus plus 8 is the month. 47. 47. Yes, 47. If I put the 5 down here, I'm going to get 8, 5, 40 plus 7 is 47. And this one was supposed to be adding what? 4. Or the 4 is already added already. So we're good to go. Then we have this line. We want to find the number over here using this line. So we're going to do, we're going to equate that number to 2n minus 2n plus 1 to see what the n is for here. Let's do it over here, so. So for inside here, we're going to put 2n plus 1 equals 47. So it means that 2n is equal to 46. Divided by 2, the n is equal to 23. So right here, so it's 23. Now that is 23, you can take the 23 and drop it on this formula right here. So to see what this is. All right? So what that is. So over here would be 4 times 23 plus 8. What I will go to? 4 times 23 plus 8. That's 100. So this is 100 flat. 4 times 23 plus 8. That's 100. And that's it. The table done. Easy like this. It's supposed to be a quickest question in the exam. This question. Quickest question. Quickest question. It says, Skylar says she can make one of the figures, one of these figures with a perimeter of exactly 105. So in other words, she wants the perimeter to be 1005. Explain why she is incorrect. Now, she's going to be incorrect if the n, the number, the figure number n is a value that is not a natural number. Or the figure number has to be accounting figures. So if there's any formula, if you put this equals 1005, and the n can't come out to be a number that is a natural number, then it means that you can't make the figure. But the n has to be a natural number, right? A counting number. So that's why the first thing you have to say. The n, for it to be correct, n must be a natural number or a counting number, natural counting number. You're going to say no. If this formula equals 1000, that's if P equal 1000, 1005. If P equals 1005, then the formula equals 1005. 4n plus 8 will be equal to 1005. Then you try to work out the n now. So you subtract the 8 and then divide the 4. So the n would be equal to 1005 minus 8 divided by 4. That's going to work out to be what? What I will put. So it will be 1005, a fraction. 1005 minus 8 over 4. I will get in 249.25, which is not a counting number. That's the reason why you can't make it, because it's not a counting number. Can I understand that? That's the reason why she can't make it. Because the n that would give you 1005 is not a counting number, and the n has to be a counting number in the pattern. All right? Something like that. Next question. Number 8. Number 8 says, functions f and g are given by these two, f and g. So first thing they want is g of 2. So another function question, give one in part 1 and it's hardly ever happens. So we're going to put the 2 in the g function here. So it becomes 5 minus 2 squared. 2 squared is 4, so the answer becomes 1. 5 minus 4 is 1. Then I want f to the minus 1 of 3. F to the minus 1 of 3. So we can do this 2 ways. Let's find f to the minus 1 of x first. So first we're going to find f to the minus 1 of x first. And then you do f to the minus 1 of the 3. Let's use that method. So we're going to start by saying the f equals, what is the f? F is 2x minus 1 over 3. 2x minus 1 over 3. I'm going to inverse it. When you inverse it, the f becomes x. And the x here becomes f to the minus 1. Minus 1 over 3. You try to make this a subject. Multiply with 3 first. You're going to get, huh? Which one? We're gone? This one? No, because you're not squaring the negative. You're not squaring that. And that you are squaring. You're only squaring the 2. The 2 is not on the negative. 2 is, the square is not on the negative. Square is only on the 2. If it was this you have, and that before, because you're squaring the negative as well. See that? So you're only squaring the 2. You good? All right. Good. So this now I want to make this. So I'm going to multiply the 3 over here so first and get 3x equals 2f to the minus 1 minus 1. And to make this a subject now, we're q over the 1 and add it and then divide under the 2. Q over the 1 first, I'm going to come with a positive 1. You're going to get 3x plus 1 first. Then take the 2 and divide under here. Over 2, and that is your f to the minus 1. That's f to the minus 1 of x now you have. You can put in back of x now. Then from this now, you can continue up here and put in the 3 on it now. So we can say now f to the minus 1 of 3 now equals 3 times 3. I'll put in the 3 here so now for the x. Plus 1 over 2, which becomes 10 over 2. 3 is 9, I want to make 10. 10 over 2 is 5. So the answer right there is 5. All right? That is it. Next part. It said, do you have an expression for f of g? Remember now, f of g, it means g into f. It means g into f. So we're going to write them down. What was the f again? The f was 2x minus 1 over 3. And the g was x squared, right? 5 minus x squared. The g is 5 minus x squared. 5 minus x squared. So this means I want to take all of the f, all of the g, sorry, all of the g, and bring it and put it in the f right here where the x is. That's how substituting f into g. That's how form a composite function. So f of g becomes 2 times all of the g is 5 minus x squared. Subtract back this one beside it and divide everything by this 3 under here. So, and I want us to simplify. So the numerator, I've expanded the numerator becomes 2, 5 is 10. Then 2 times minus 2x minus x squared is minus 2x squared. Yeah, but this minus one out here, divided by 3. So then it becomes equal to, this 10 minus 1 is 9. So it becomes 9 minus 2x squared over 3. And that is the answer, right? Can't leave it like that. Very good. That is it. Next question. Said, sketch the graph of the function g. The state provided below. On your sketch, indicate the maximum or minimum point and the roots of the function. What is the number one? G. The G number one, say, the quadratic. I want this. What's the sketch that graph? It's quadratic graph. So, wow. All right. So let's do it down here. Put the summary down here for it. So the G function is 5 minus x squared. We know it as x squared minus x squared plus 5. Now, when it is like that, guys, when it is like that, right? This x squared, you have written as x minus 0 squared. I want to get it in the form x minus xt squared plus yt, you know. I want to get it to look like this. When it look like this, we know what the turning point is. Get me? You know what the turning point is. So it's two values there. So this is like it's like the yt right now. And this is the only x term in it. So what we're gonna do, we're gonna take this, and this will be a negative. This will actually be a negative one because of the minus. This will actually be a negative one. This will be a negative one, right? So I'm gonna change this to x minus 0. So it becomes minus x minus 0 squared plus 5. What that mean? Xt is 0, yt is 5. Right? Xt is 0, yt is 5. So xt, yt becomes 0, 5. That's your maximum point. It's your maximum point. Right? And then if you want to find the roots is where you put this equal 0 now. Remember, the roots are the point where the y value is 0. So this is the maximum point. The question asks for that. The question asks for the maximum or minimum point. We know it's going to be a maximum. Why is that maximum? Because the square term negative, right? Square term negative. Remember, it is g equals 5 minus x squared. Square term negative. So it's going to have a maximum. So it asks us for the maximum. We know it don't have a minimum. It's a maximum right at that. It also asks us for the roots. So we have to find the roots. Roots is the point where the g equals 0. The g is like y. So the roots is the point where g equals 0. So see here now, roots is where the g equals 0. So you put this equals 0. So they put that in here. What did I do? Okay, keep pressing around it. So we put 5 minus x squared equals 0, which means that x squared equals 5. So it means that x equals plus or minus the square root of 5. So those are the roots, plus or minus the square root of 5. What is plus or minus? Because when you calculate square root, whenever you calculate square root of a value, you have to consider plus or minus. So plus or minus the square root of 5. Square root of 5 is how much? 2.23. So it's plus or minus 2.24. Those are the roots. So those are the x values where intersect x-axis. So based on that, the roots are 2.240 and minus 2.240. Those are the two roots. These are the roots. These are the roots. And this is the maximum point. I put this in a red. So I kind of quickly work out what they asked us to show. Right, so we need to sketch that graph now. They didn't give us any scale. So we put on a little bit of scale on it. So put this like 1, put on the scale in it so you can see it. It's like 1, 2, 3, 4, 5. Make this be 0.5. So that's where it turns, turns at 0.5. Turns at 0.5. And then we pass through 2.2, 2.24, positive and negative. Let's put this as 1. Can't make this go wider. Make this be 1, 2, 3, -1, -2, -3. So in terms of where it pass through, it turn right here. So it's at the turning point, 0.5. 0.5 is the turning point. That's where it turns. And then the pass through 2.22, 2.2 something, right? So 2.2 would have been about right here, so. And the negative 2.2 would have been about here, so. Negative 2 about here, so. So you pass through those points. So you want a frown that pass through those points and turn here, so that is the sketch. So we cannot do like this. And give them that and it's supposed to give you a marks. Something like that. Give them that and it's supposed to get a marks. So I have to kind of work it out. So this is 2.23. This is negative 2.23. We have to work them. We have to work what the maximum point was. And from this, you could have calculated the xt and yt same way, from this. Because the A will be equal to -1. The B will be equal to 0 because there's no x value there. And the C will be equal to 5. Right? So you could still use this and calculate the xt and yt. Use a formula if you want to. The A will be -1. Coefficient of the x squared is -1. There's no x value there, so the B is 0. Right? That's why we calculate xt is minus b over 2a. The b is 0, so it's minus 0 over 2 times -1. So it's going to be 0. See? The xt value is 0 right there. So you could have gotten it from that method as well. Questions like this are special, guys. You have to pay attention to them and do them over one another. Right? Questions like this, you don't just leave it like that. Special question is unique and different. All right, that finishes it. This question says, the graph below shows a quadratic function. It says, on the grid below, draw the tangent at x equals 1. So I showed how to draw a tangent at x equals 1 at any point actually. X equals 1 is right here. X equals 1. On the graph, it is right at this point. What is that? This is the point on the graph where x is equal to 1. And I want to draw a tangent there. Tangent is a line that touches the curve at a single point only. So x equals 1. It's right here on the graph that is right there. So they want the tangent at that point. That's the point where x equals 1. And the tangent now, you get the tangent. It's like you line up a ruler against it like so. Line up a ruler right against it, so you just touch it. Line up a ruler against it like that. And then when you line up a ruler against it, you just draw the tangent line down against it like this. Right? You must just touch it though. Something like that. So you just touch it. This device is not so friendly, but that's what you do. Everybody get a picture? But that will be a rule. Line up against the point right here. Right against it. And then kind of parallel to the curve right at this point. And then you just draw a tangent against it with the ruler. What I normally say to you must do, put your pencil on the point, Put your pencil on the point itself, and then you position the ruler against the pencil. Put your pencil on this point, and then position the ruler against the pencil, and then straighten it, and then draw the tangent. I showed you that in class, all right? But I want you to draw that tangent at this point. And I'm going to say it is, that looks all right. That looks all right. Anybody did it? Wanna get? I'm trying to draw it. Maybe something like that. I want to draw it properly. I want it to look like a tangent. Cross it. All right, I repeat that. Let's say that is the tangent, right? And the tangent passes through this point, and that point is clearly 1, 3. And let's say the tangent passes through this point, which is 0, -1. We want to find the gradient of the tangent now. This is the tangent. Sorry, if you want to find the gradient of the curve at this point, then you find the gradient of the tangent using these 2 points. We did that in class. Anybody remember us doing that in class? We did it in class, right? To draw tangents, curves to find the gradient. Sit here now, let me say, sit here now, use a tangent drawn to estimate the gradient of a curve at x equals 1. So I'm going to use those 2 points. So the gradient of the curve equals the gradient of a tangent. Gradient of the curve at x equals 1 equals gradient of the tangent at the same point at x equals 1. So if we want to find the gradient of a curve at that point, we find the gradient of a tangent at that point. And those 2 points are the tangent. So it becomes difference in y over difference in x between those 2 points, right? I can just calculate the rise over the run between those 2 points. So we can count off the rise and the run. We can count it off. Let's do it in green. So what is the rise up to here, so? The rise up to here, so is what? What is the rise? 1, 2, 3, 4, right? The rise is 4. Rise 4. And the run is 1 unit. This is just 1 whole unit, you know. That's 1 unit run. You don't count the box for the run, you count the units. So the run is 1 unit. Run 1. You see it? 1 unit. All of this is 1 unit. Don't count the boxes, you count the unit. So the run is 1 unit. Say 1 out here, so. So it rise 4 units. The scale on the x-axis and the scale on the y-axis is different. So to be careful. Don't count the grid, you have to count the units. So the gradient is rise 4 units over run 1 unit. So the gradient is 4. I've used these values to calculate it. Or if you difference in y have a difference in x, it will be 3 minus a -1. See there? 3 minus a -1 over 1 minus 0. Over 1 minus 0. If you use the coordinates to do it, over 1 minus 0, still going to get 4 over 1. If you did that one, use the points to do it, which is equal to 4. All right, so you get the same thing. All right, that's the one thing I'm going to do in the last 3 questions because we just did it the other night in the marathon, or this last part. It says, write down the equation of the tangent. So the gradient is 4. Gradient is 4. And the c is -1, right? See there? C is -1, don't it? But the y is at -1, that tangent, right? The gradient is 4. So the equation is y equals 4x minus 1. That's the answer. So these last questions, just did them the other night. just did these questions Saturday night in the marathon. Right? These questions. We just did all of these questions Saturday night. These questions. So I'm not gonna bother to do them now. It's late. Right? I'm gonna just show you the video. Yeah. Video is done. The video is in the group. I'll bring up the video and show you. So this time bring it up on this device. So we did it the other night. Where is it? We did it the other night. Where is it? Where is it? Someone's video my way, so. Search Rafik Shah Marathon. Search Rafik Shah Marathon. Right, you hear this video. So we did this the other night, guys. So you can go and watch the solution for those questions. So them at the end here, so. All right, those same questions that we just did the other night. See them there? Same diagram, same question we just did the other night. So you can go and watch this video. Look for this video. CSEC Math Class Revision Marathon, April 26, 2026. I see the solution for those questions. But I'm going to show the solution so you can check on the answers now and tell me what you're going to get. But the solution for it was done in this video. Those three questions, all right? All of them is in this video. See them there? So I'm not going to bother to do it now. I will do them just that and 26, just that and so all of those questions were done. Cool? All right, guys? These same questions I did the other night in the marathon session. Same questions. All of them. So let me bring up those same solutions. And you check your thing here with it. Let me show you. 2024 solutions. So this is the working out that we did before. Same paper, same diagram, same everything. There you go. The widths and the method for some of them. Here's a graph that we did a while ago. Here's a tangent, and I will just draw. Same gradient, same equation. Here's the solution for this one. Come on, go in. Check on the score and tell me. So the answer them for this one here. Explain why that angle is 62 degrees. Angle the same segment are equal. X1. Why this angle is 124? Because angle of center is twice angle of circumference. That's what we did. Then this one down here, why is that angle equal to 90 degrees? Because angle between a tangent and a radius is 90 degrees. Then answer these angles down. First answer there is 62 degrees. Next answer there is 28 degrees. Then answer E is 44 degrees. Then we have this bearings question. The actual length QR is 7.61 meters using cosine rule. And this one was 108 degrees and 0.25 degrees for those bearings. And the next question, V was 6. Next question, that product was -2, -2. That vector was -2, -2. Next question, this was the inverse right here. You can see it down here. That's inverse. Look at it. Good. 2/3 -5/3 -1 3. Then this one Q was 3 -1. That's the answer for that one. 3 -1. For this question, AD was 2B minus A. BC is B minus half A. And down here, I have to do all of this thing and get the relationship between them. AD is 2 times BC. That's the answer. AD is 2 times BC. AD is twice the length of BC. That's the answer for this one. AD is 2 times BC. And that finishes it. Anyone know how we look back at? Tell me. What more how much I get? But these questions, the solutions are on the video that I've just showed you. So you can search for that video and watch the solution for these. I don't have to do it over again. But today I just do them some Saturday night. So people online send me a text message how much I get. Abigail, tell me how much I got. Everybody online, tell me how much I got. Some people online, some people online. Dejane, tell me how much I got. Jadine, how much I got. Jador, how much I got. Casey, how much I got. Terry, how much I got. Huh? 100 marks. These people mark out of 100 marks. 100 marks. So add up the marks and out of 100. Huh? 85. Good. By the way, we're doing an assessment work Wednesday and Thursday. All right, so come Wednesday and Thursday, the mock exam we're doing again Wednesday and Thursday, but it's going to be assessed. It's so good. Think over 80 right now. Good. If I get less than 80, still have to go over the question I get wrong enough. Still do over the 18% we get wrong. Still do over the 15% we get wrong. How about you? How much you get? 71? 77? Close enough. So do over the question I get wrong. How about you? You know what do the paper? Huh? Why don't come under the paper then? And if you don't come under the paper, I send the papers in the group. I send the papers that we're doing in the group every time. 77 that's not bad. We're marking right and wrong and get 77, that's good. But so give me 80 something of the week. I'm gonna say we have 2 more papers Wednesday and Thursday. Give me the 80 something of the week. How about you? 79? Huh? All right. People online, text me. I'm looking for the text. Text me and tell me what you got. People online, text me and tell me what you got. I want to hear. And be honest. Don't cheat yourself. Send me a WhatsApp of how much you got. How much you get, mom? Huh? 70 flat? All right. So the question I may get wrong, you know you must do, right? I'll work them over again. Watch over the video. All right, guys, online, I'm going to end the session now. You send me a text message of how much you got. I'm going to end the session now. Bye, everybody. Okay, Wednesday. Okay, exam again, Wednesday and Thursday.